You can go.
Okay, so my presentation is over maximizing profits in a business using calculus. So let's start off with a simple scenario. So let's say a business wants to start selling calculators, and they notice that when they price the calculators at $40, they sell 1,200 of them. And whenever they price them at 45, they sell only 11.50. So they notice that with every $5 increase in price, there's a 50 decrease in units sold. So they would like to know at what quantity and price would they make the most profit. And so how would we do that? Well, in economics, the profit that a business makes is represented by the profit function, which is just revenue minus cost in terms of X items. And so if revenue and cost are differentiable for X in some interval of production possibilities, and if that profit function has a maximum value there, then it must occur at a critical point of the profit function. And so if it occurs at a critical point, then when we take the derivative, it has to equal 0. And from there, we can see that r prime of x must equal c prime of x if they're to be subtracted and equal 0. And in economics, r prime of x is referred to as marginal revenue, which is just how much revenue you make for producing one extra unit of a specific something. And c prime of x is referred to as marginal cost, which is just the cost to you of producing one extra unit. And so if r prime of x and c prime of x are equal to each other, that means that at a production level yielding maximum profits, marginal revenue must equal marginal cost. So in order to find this, we must first calculate our revenue. And so we can do that by finding a relationship between price and quantity using our slope formula, which is y2 minus y1 over x2 minus x1. And we get negative 10. And then we plug that into our point slope formula, and we get q minus 1200 equals negative 10p minus 40, which simplifies to q equals 1600 minus 10p. And then from there, we can find the price just by solving for p. So we just subtract the 1600 and then divide by negative 10. And we get price equals negative 10q plus 160. And revenue in terms of items is just that price in terms of quantity times quantity. So then revenue in terms of quantity is 160q minus 110q squared. So that's how you find revenue. And then finding cost is much easier. Let's just say that every calculator you produce is going to cost you $30. But as a business, you also have fixed cost every year, which is just like running the amount that it would cost you to run the factory and all that physical capital. So then our cost function is just simply 2,000 plus 30q. And then we can, now that we have our revenue and cost, we can plug that into our profit function. So we get 160q minus 110q squared minus 2,000 plus 30q. And if you were to actually subtract that, you'd get profit function equals negative 1/10 q squared plus 130 minus 2,000. So now all that we have to do is just find a derivative of our revenue and of our cost. And so to find the derivative of 160q is just 160, and then the negative 110q squared just becomes negative 2/10 q. And so then that simplifies down to 160 minus 1/5 q, which is our marginal revenue. And then marginal cost is easy to find. The derivative of that is just 30. And so now in order to find a profit maximizing quantity, all we have to do is just equal them to each other. And so we get 160 minus 1/5 q equals 30. If we subtract the 160, we get negative 1/5 q equals negative 130. Then divide by the negative 1/5, which is multiplying by the reciprocal, we get q equals 650. So this means that the profit function has a critical point at 650, but we do not know if that is a maximum point or a minimum point. So we're going to have to use our second derivative test, which will tell us that. The second derivative test lets us know if the critical point is maximum or minimum, depending on if the second derivative is negative or positive. If it's negative, that means it's going to be concave down, and it's going to look like this. So that means it's a maximum. And if it's concave up, that means it's going to look like this, and that means that point is a minimum. So when we take the first derivative, we get negative 2/10 q plus 130. We take it again, then it's just simply negative 1/5. And that is negative. So that means our function is concave down, and that in fact is a maximum value there. And so to find the maximum profits, all we simply must do is just plug in that 650 into our revenue and cost. And we get 61,750 in revenue and 21,500 in costs. When you subtract those, you get a profit of 1,250. And we can test that that is the most this business can make by simply inputting a number different. In this case, I use 651. And we can see whenever they sell 651, they only make 40,249.9. That's one way to figure it out. There's also another way to find maximum profit, which is simply by finding the vertex of your entire profit function and then equaling it to 0 to find the critical point. So when we combine the product function, we get negative 110q squared plus 130q minus 2000. Take the derivative of that, you get negative 2/10q plus 130. You equal it to 0. You subtract your 130, then you multiply by the negative 5, and you get q equals 650 again. If you plug that into this function, you also do get the 40,250 in profits. This graph shows marginal revenue and marginal cost graphed, and we can see that the point that they intersect is the point where they're equal to each other, which is in fact 650. And then this graph shows revenue, cost, and profit all plotted. And at 650, we do see that the revenue is the 61,750 that we got, and the cost is the 21,500 that we got. And the difference between those is the 40,250, which we can see is the maximum value of the profit function. So that means 650 is in fact the profit maximizing quantity, and that is the most that this business can make. And that's it. How do I